Number 8, energy analysis of toys. We're going to do one quickly together, and then you'll do some. A. Actually, go ahead and think this through. And if you haven't done a popper yet, pop a popper, but I think you've all done it. So below each of the diagrams, draw the energy pie chart.
Would that be energy right here? The diagram's here?
Right below each one, draw the energy pie chart for each position. And the system is defined there. And this is part A, says draw energy pie charts. While you're doing this, you probably will need to think about forces and what forces are internal and what forces are external, because you have to be able to tell when energy gets transferred into a system or out of a system. If you guys are done with your pie charts, answer B and C.
Is there any external forces?
So think about all the things that happen from A to B to C to D to E. Between A to B, well, what forces are there at A?
No.
Well, there's the normal force and gravity.
Normal force and gravity.
And same at
but
B.
neither one does any pushing through any kind of a displacement.
Right.
So no transfers there. What about in between A and B? What happens?
Something pushes down.
What do you have to do to get this thing ready to go?
It's elastic, isn't it?
Invert it.
I have to push with these fingers down, and I have to push through some distance. And these fingers are actually pushing, the outside fingers are actually pushing up through some distance.
Well, but they don't have to. They could just do the same.
I could just do the center?
Yeah.
Oh, I guess I could just think of that as a surface, right? So I have to do a force through a displacement. Is that an external force?
Yes.
Am I part of the
Yes,
system?
I suppose so.
No.
I am not part of the system. So that is an external force.
That's the only one, though.
So what does that external force do? Right here I'm doing work. And now at B, we have, if I let go, we have the normal force and force of gravity again, but they don't do any transfers of energy. In C, when it's flying through the air, what force is acting?
Gravity.
Gravity. Is that internal or external?
It's internal.
That's internal. So that's going to cause a change in storage modes, but not in total system energy. The change in total system energy happened right here. It went from 0. So your very first, for A, you should have a dot, no energy. For B, you should have a circle. And in the circle, you should have elastic potential energy.
Question.
Yeah.
So the act of this moving to this creates friction, right? Because
That's a good point.
But then the friction's lost in the air once it's in the air.
So you're thinking in more detail than we're going to get into usually. You could say that this act of bending increased the internal energy of the molecules. Is that what you're thinking?
Mm-hmm.
You are right. Technically, that did, like right if you bend a paper clip, it warms it up. So we are usually going to neglect that transfer.
Okay.
But if you put it in and you explained it, I would say, yeah, you're right. That would be fine.
And then if
Wouldn't
it's
be
moving
wrong.
in the air, doesn't it have with the velocity, wouldn't it have the kinetic energy?
So let's see. Okay, so part B, we're all good with elastic potential for the whole circle?
Yep.
Okay, part C, I have part of the circle, same size circle as in B, but part of it gravitational potential and part of it kinetic. And then what do you have?
Gravity, internal, and kinetic.
So internal energy from what?
From the friction.
From this?
Yeah.
From the
that
bending?
Mm-hmm.
That is technically correct.
Okay.
I wouldn't expect you to include that. Usually we will
But then
only include...
it is lost because the energy is going to transfer into the air, right?
Okay, so we're also not today going to consider any transfers to the air.
Okay.
But you're getting into all the nuances that make analyzing energy really interesting, right? Because you get to decide at what level do you want to analyze it. You know, we're kind of looking right now at the bigger pieces. And usually when we do internal energy, what I will expect you to be able to do is when there's friction. When there's friction between surfaces.
What about between like the same?
But I wouldn't expect you to include that internal energy. but you can, it's not wrong. At D, at the highest point, assuming no internal energy, what would you have in your pie?
Just gravity.
Gravitational.
Just gravitational potential, because at the highest point it stops, assuming it went straight up and it's not going sideways. And in the last circle, the instant before touching,
Kinetic.
Okay.
all kinetic. Okay. Part B, what external forces caused a transfer of energy in or out of the system? That would be the external force of your hand on the popper, and that happened between A and B. So what I would like you to do is draw a bracket. I didn't draw it, but draw a little bracket between A and B and put, draw, I don't know if you can draw the direction of the force. In part C it says draw force vector. So during that time, there was a force of my hand down and there was a displacement down. And that's what caused that transfer of energy. I'm not sure they'll be able to see that on the video, but between A and B, there was a transfer of energy in by the force of my hand, which was an external force, over a displacement. Okay? Okay, I'm going to let you guys do the experiments now, which are on the very last page, and we're a little bit behind, so let's maybe take 15 minutes and see what you can get done.
Are we doing
There
right
are
time?
4 scenarios, so you guys can be in 2 lab groups. There's 4 scenarios: the frog on the spring, the push and go toy, the fly swatter gun. Please don't point it at anybody's eyes, okay? Or I can get you safety goggles. And 4 is for the marble coaster. There's a marble probably laying on the track somewhere. Put it underneath. A is right underneath B, so put it on the floor, and then you're going to pick it up and set it on the track and let it go.